Okay, so I'll be recording this session for those who are not able to join our session tonight. Okay, so let's start. So let us start, yeah. Okay. So question number 1. In this question number 1, the diagram shows an arrangement of apparatus to study the pattern of magnetic fields which are formed when the current flows through the conductors. So which magnetic fields pattern is formed on the cardboard when both switches are closed? When both switches are closed, it means that it is dia adalah dalam keadaan switch on. Okay, this means that it is switch on. So if it is switch on, you have to determine which magnetic field pattern is formed on the cardboard. So to identify which is the correct pattern, so you have to know the direction of the current flow. The direction of the current flow is always from positive terminal to the negative terminal. So let's say this one, the switches are already closed. Okay, the switches are already closed. Both are closed. So the current will flow from positive terminal to the negative terminal. Okay, so it will flow here, and the ones that we are taking into consideration is the one where it goes into the paper or into the cardboard, which is this part here. Okay, part here lah, ini dengan di sini. So what type of rule are we going to use for this one to determine the magnetic field on the straight wire? Which rule are we going to use?
Left.
Left?
Oh no, right.
Right apa?
Right hand rule.
Right hand grip rule.
Grip.
Yeah. So we will be using right hand grip rule. Okay, right hand grip rule to determine the pattern of the magnetic field around the wire. Okay, so on this part here, on the left hand side, the current is going upwards. The current is going upwards. So you use your right hand. And your thumb is pointing upwards. Your thumb is pointing upwards, so your other fingers is indicating the direction of the magnetic field around the straight wire. So what is the direction of the magnetic field around the straight wire? If I draw a circle here, so the direction should be apa? Clockwise or anti-clockwise?
Anti-clockwise.
Yes, it should be, the direction should be anti-clockwise. Okay, anti-clockwise. The arrow is to take anti-clockwise. All right, anti-clockwise. Now the other part on the right hand side, we still need to use our right hand grip rule to determine the pattern of the magnetic field. So again, you look at where the current flows. So it is always from positive to negative. So current will flow and it will be going upwards. So again, by using your right hand grip rule, determine the direction of the magnetic field around the straight wire. Okay, so dia punya direction is, it is still, is it the same? Yeah, anti-clockwise kan? It should be pointing in the direction of anti-clockwise. Anti-clockwise. Okay, so now can you determine which one is the correct answer based on your findings there? Determine which one is the correct answer. Mana satu? A, B, C, D.
B.
B. Semua cakap adalah B. Okay, let's see ya. Yes, the correct answer is B. Okay, so both, because both sides is pointing the direction anti-clockwise. Okay, both of the magnetic field patterns on both sides is in anti-clockwise direction. All right, so answer is B. Okay, next question. Question number 2. Okay, question number 2. Diagram 2 shows a coil of wire placed next to a magnet. The galvanometer pointer deflects when the magnet is pushed into the coil. So which action will increase the deflection of the galvanometer pointer? Which one? A, B, C, D. Increase the deflection. Answer should be, kalau A, tidak kan? A, the magnet pole is reversed. This one, no effect. B, the number of coil is increased. Number of coil, this one is capital N. Increase should be apalah the right answer. C, the coil is made from insulated wire. Tidak berapalah dia punya apa, not the correct factor that we are looking for. And D, the magnet is pushed slowly into the coil. So push slowly, so dia punya cutting of magnetic field also will be slow. So the deflection will also be less. So the correct answer should be B. Right? Correct answer is B. Okay. Number 3. Question number 3. Diagram 3 shows a magnetic field pattern when currents flows in a straight wire. So which of the following shows the correct direction of magnetic field for compass P and Q? Okay, so this one is the same like in number 1. So you use your right hand grip rule to determine the pattern of the magnetic field. So coba dulu. So what will be your answer for number 3? B juga, yang lain? Leandra pun bilang B. The rest, do you agree the answer is B? Helen pun bilang B. B. Okay, let's check the answer. Yeah, the correct answer is B. So again, we determine dia punya apa tu position of the flow of the current, which is from positive to negative. So it should flow here. So the current is going into the paper. So your thumb is pointing downwards, and then your other fingers is indicating the pattern of the magnetic field, which is clockwise, in the clockwise direction. Okay, clockwise direction. So if you put the compass in the position of P and Q, so P should be going down. Okay, P should be going down. Inilah kan? P should be going down, and then Q, it should be pointing left. Okay, it should be pointing left. So the correct answer is B. Right? Correct answer is B. Okay, next question. Number 4. Question number 4. Diagram 4 shows a simple transformer. The current in the primary coil is 0.1 ampere and the efficiency of the transformer is 60%. The output power of the transformer is, so we have here the information given in the question is we have input voltage 240 volts. So this one is VP. Okay, this one is VP. And you are also given the output power, which is 6 volt. So this one is secondary voltage, VS. And you are also given the current in the primary coil. Current in the primary coil, so this one is IP. Efficiency of the transformer is 60%. So you are required to find the output power of the transformer. Output power. Can you do the calculation? Try and find the answer dulu for this one. Faiz bilang B, 14.4. What about the rest? Did you get answer dia B? B juga. Yes. Check, we check the answer. Yes, correct answer is 14.4 watt. I don't need to show dia punya workings, kan? Do I need to show the workings or no need? Show juga. Okay, so formula yang kita guna di sini, for efficiency, we will be using efficiency. Power output over power input, POPI times 100%. Kan? This is the formula. Now for power we have, this is the formula for power. P equals to IV. So you can do this one. VS, sorry, IS VS over IP VP times 100%. Okay, since you are given the efficiency is 60%, so straight away you put that one, 60%. And then itu 100 you kasih pindah pergi ke sebelah kiri, so it will become 60 over 100, 0.6. And then so we have apa lagi sini nih? Good job. Do we need to find the value of the output current? Perlukah kita cari itu output current dulu? No need kan? This one dia punya input power dia ialah 0.1 you multiply with 240. Yang di atas is I leave this one sejak begini. because it is referring to the power output. So the power output ISVS is equal to 0.6 U times the 0.1 times 240 again. So it should be equals to 14.4 watt. Okay, 14.4 watt. Same lah. Okay, power output is equal to 14.4 watt. Okay. Okay, sudah 14.4 watt. Then number 5, question number 5. Diagram 5 shows two magnets J and K hang freely at both ends of the solenoid. Which observation is correct when the switch is turned on? Now, which one? Which one will be the correct answer? Mana satu jawapannya? C. Oke, yang lain? Let's see the answer. Answer for this one is D. Answer is D. D. Dia punya J apa nih, moves towards the solenoid and magnet K moves away from the solenoid. D. Okay, kita check how to get dia punya answer. At first, okay, so when the switch is closed, okay, dia sudah close di sana. So the current will flow from positive to negative. So it will flow there. This one will be going up. Okay, the arrows are all pointing upwards. And then what type of rule do we use this one to determine the direction of the poles on the solenoid? Kita guna apa? What rule? When you have the direction of the current, so you can use apa? What rule? Mana sudah Cibu punya tangan itu? Where is the... Tiada sudah.
That means right hand rule.
Ya, itu. Right hand grip rule. So you use your right hand grip rule. Okay, so now your fingers your other fingers is pointing upwards. So your thumb should be pointing to the left. Your thumb should be pointing to the left, indicating the direction of North Pole. So maksudnya this side here, it should be North Pole. And on this part here, it should be South Pole. South Pole kan? So, what will happen to magnet J? Magnet J on the right hand end there is south. So, south and north are both opposite poles, so it will be attracted to it. And yang di sebelah kanan, this one is north, this one is south. Both are opposite poles, so it should be attracted to one another. So ngam kah itu? Jawapannya tidak ngam kan? Ya, so actually dalam ini buku dia salah. Jawapan dia adalah salah. Kalau D is the answer, then it is incorrect. So the correct answer should be C lah kan? Because both of the magnets should be moving towards the solenoid. Both are moving towards the solenoid because both ends have opposite poles, so it should be attracted to one another. Ngam? Do you agree the answer is C and not D? And yeah, it should be attracted. This one also should be attracted to the solenoid. So answer is C. Okay, answer is C and not D. This one is not D. So that's why sometimes then it is important for us to discuss the answer, especially yang objective tu lah, to verify whether the answers given in the book is correct or not. Right? So C. Jawapannya adalah C. Okay, next question, number 6. Question number 6, diagram 6 shows a bulb 24 volt and 18 watts. So we have here values for, this one is V, this one is for power. V and this one is for power. Lights up with normal brightness. What will happen to the bulb when the number of turns in secondary coil increases to 50 turns? So which one will be the correct answer? B. B. Okay, kita cek dia punya jawapan. What will be the answer? Answer is blown up. Dia akan terbakar. Why? Why is the answer C? Dia terbakar. Any idea on how to get the answer? You try and find dia punya apa dulu, output current. You try to calculate dia punya output current dulu. Now, for the output current, you can calculate by using the formula apa? For output current, we can use this formula kan? I times V. So to get I, P over V. Ini adalah this part here. So I S, the output current, this one is 24 over 18, which is equals to, terbalik, sorry. 18 over 24. So the current, output current should be 0.75 ampere. Okay, 0.75 ampere. Now we have here, dia punya number of turns. This one is NP, this one is VP. We also have inilah dia punya NS. NS is 10, IS is 0.75. So if you increase the number of turns in the secondary coil into 50 turns, now it will become NS equals to 50. Try and calculate itu dia punya output current dulu. If it is more than 0.75, if you get the answer for the output current more than 0.75, then memang betul the bulb will blow. Jadi, how to get dia punya apa nih? Can you calculate dia punya IP dulu? Try to find IP dia dulu, and then later on we will try to find dia punya IS, the second part. So kita boleh guna VP IP equals to VS IS. Cari dia punya IP, VS IS over VP. So dapat berapa sana tuh? You divide by 240. So the input apa tuh? Input current should be 0.075 ampere. Oke, sekarang coba kira dia punya IS. IS by using NS equals to 50. Dapat kira? Did you get the answer? Oke lah, kalau yang ini kan sebenarnya if you are stuck with the calculation, actually kita boleh determine dia punya outcome. So macam yang ini kan, we have dia punya output current or the current in the secondary coil is equals to 0.75 ampere when the number of turns is 10. And then yang sana input dia tu when the voltage is like this one. Now when you increase dia punya number of turns into 50, means dia increase 5 times. This one increase 5 times. So let's say kita ambil itu dia punya value di sana tu, and then you just times 5. You just times 5 with the value. So of course, the values of the secondary current will be higher. So that's why dia punya answer di sana kan, the bulb will blow up. Okay, the bulb will blow up because of excessive current flowing through the bulb. Dia tidak dapat menampung sudah. So it can only hold up until 0.75 saja. More than that, then it will blow. Okay, so the answer is C. Okay. Bah, soalan 7. Number 7, what will be the answer for number 7? C. Okay, check. Yeah, answer is C. Yes, number 7, the answer is C. Electricity is transmitted at a very high voltage in order to reduce power loss. Memang itulah dia punya reason. Okay, number 8. Question number 8. Okay, what is the answer for question number 8? We have here, this one is power, this one is R, resistance, and this one is the voltage. So to get power loss, to calculate the power loss, first you have to find dia punya apa dulu kan, the current flowing by using P over V. P over V. Now P is the power, 50 kilowatts. Don't forget to convert yang kilo dia tu to in the full form. So kilo is 10 to the power of 3. And the voltage is 10 kilovolt. So 10 times 10 to the power of 3. So you should get the current flowing is 5 ampere. 5 ampere kan? Ini sudah kena cancel. 0 is cancel, so dapat 5. Next, to calculate dia punya power loss, we use this formula. P equals to I square R. Coba kira dulu berapa dia punya jawapan sana. P equals to I square R. $100. Yang lain? Okay. Check. Answer is, yeah, 100. Answer should be 100. So you 5 square times with 4. So it should be 100 watts. Okay. Answer is C. All right. Next, number 9. Question number 9. Number 9. An ideal transformer has 400 turns in the primary coil and 580 turns in the secondary coil. Okay, so again, we identify this one, NP, and 580 turns in the secondary coil. This one is NS. When a 240 volt supply is supplied to the primary coil, so this one is VP, an 8 ampere current flows through it. So this one is referring to IP lah kan. What is the current in the secondary coil? Current in the secondary coil, so we are going to find the value of IS. Okay, coba kira dulu what calculate first? What will be the answer for this one? You need to find apa dulu? You need to find VS. After you have find the value of VS, then easier to find dia punya IS lah. Cari apa dulu? VS. Cari VS dulu. Answer is D. Leandra bilang D. Yang lain? Check. Yeah, answer should be D. Yeah, D. Do I need to show the workings? Ya payahlah kan? If you already got the answer. Mau juga show? Show juga, ba. Okay, so kita cari dulu dia punya VS kan? So we are going to find the value of VS first by using this one. VP over NP equals to VS over NS. Ini dulu kita cari. Now to get VS is VP over NP times with NS. Okay, substitute into the equation. VP is 240, NP is 400 times with NS 580. Jadi dia punya apa tuh? VS you should get 348 volt. Oke, itu untuk VS. Now to get dia punya IS, then we can use this formula by using adalah VP IP equals to VS IS. So to find the value of IS, VP IP over VS. VP is 240, IP is 8, so VS 348. Right? So you should get 5.5 ampere. Okay? Dapat ah? Ya, kena buat double lah dia punya workings di sana. You try to find one by one lah. So that is the correct steps on how to get the answer. Looks complicated, but it's not. It is actually not, because the formulas are all given and just basic formulas sahaja. Alright? Okay. Question number 10. Question number 10. Yeah. Question number 10 diagram shows the structure of an electric motor. What type of electric motor is this one? Is it DC motor or AC motor? DC or AC? DC because ada battery di sana. Okay, if you see a battery in the circuit, it means it is a DC motor. Okay, so question there, which of the magnetic field pattern is correct when the motor is switched on? So which one? So what law ataupun rule should we use here? What rule? If you see a battery that shows the positive terminal and negative terminal, so you should be using what rule? Left hand rule. Okay, Fleming's left hand rule. So we use your Fleming's left hand rule to determine the direction of the force and also the catapult field. Fleming's left hand rule. Okay, so on both sides, after you have determined dia punya positive and negative terminal, this one is positive, this one is negative. So the current will be flowing where? According to dia punya direction in the coil kan. So on the left hand side, on this part here, on the left hand side, determine the direction of the force by using your Fleming's left hand rule. Cuba dulu. Is it going up or down? Okay, it should be going down. Alright, so I draw dia punya arrow di sana tuh. On the left hand side, the arrow for the force should be pointing downwards. And then on the right hand side, the force should be pointing upwards. Okay? Ngam? Ngam. Okay, so based on that one, which one do you think is the correct magnetic field pattern? Oh, sekejap ah. This one kan on the left hand side, kalau kita tengok daripada depan, the front view. If you look at the front view, yang on the left hand side, the current is pointing at the back kan, pointing at the back. So this one kita assume that the current is going into. So the current is going into this part kan, sini current going into, so means dia punya symbol is X. Kita hanya nampak ujung belakang arrow tersebut. Okay, we only see the back end of the arrow. So X means current is going into. Current going into. And then on the right hand side, the arrow is pointing in front. The arrow is pointing in front, so we assume that we will see the tip of the arrow. So the symbol here should be a dot. This one I put current in. This one is current out. Okay, current out. So based on that one, which one do you think is the correct answer? Mana satu? A, B, C, D. Which one? B. You check ah. Ya. Sepatutnya B lah kan? Why B? Okay, kita compare with what we have got earlier. So yes, on the left hand side, it should be X. should be X because current in, and then on the right hand side it should be current out, so ada dot kan, this one dot. And then untuk yang diagram B, you can also check by using your Fleming's left hand rule to determine the direction of the force. So yang di sana X itu on the left hand side, your middle finger is pointing in. Your middle finger is pointing in because current is in. Your index finger is pointing to the right. So your thumb, it should be pointing downwards. Sini kan? If you are required to draw the direction of the force, so make sure you draw the arrow like this one. So this one, I label as F. And also on the right hand side, you also need to draw the arrow indicating the direction of the force. Okay. And for this one, yang catapult field, if the force is going downwards, then dia punya garisan yang di sebelah atas itu must be more than what is up. Okay, like this one lah kan? Yeah. So this should be the correct diagram to represent the DC motor in diagram 7. Okay, so yang lain-lain itu memang salah lah dia punya diagram. So there are only two possibilities of answer, either B ataupun D. So make sure you know how to apply your Fleming's left hand rule for this type of question lah. Okay, is it clear for this one? Clear. Baiklah. 11. Question 11. Diagram 8 shows an ideal transformer if the 60-watt bulb lights up with normal brightness. What is the primary current, IP? What is the primary current, IP? So the word ideal transformer means power in ataupun power input. The input power is equals to the input power is equals to the power output. Okay, that is what is meant by ideal transformer. So in the diagram you have this one is VP. You are required to find IP. This one is VS. This one is P. So you need to find apa dulu? You need to find berapa dia punya IS. Coba kira berapa dia punya value of IS, the secondary current. What is the value of the secondary current, IS? Yeah, correct, 0.25. By using 60 over 240. So this one is 0.25 ampere. Now to find IP, it is based on this one. Nah kan, power input is equals to power output. So VP IP equals to VS IS. Tapi actually kan you don't need to find dia punya IS to answer this question. No need to find. You straight away use the value of 60 to represent dia punya output power to find IP. So what is the value of IP? Did you get the answer for IP? Yes, answer should be D, 2.5 ampere. Okay, 2.5 ampere. Okay, next one. Next question. Okay, so yang ini, later on we will try and discuss this one. I don't know if your book have the answer for this. Adakah jawapan di buku apa tuh, workbook kamu tuh? Ada jawapan? Ada jawapan kena bagi? In your workbook. Oh, tidak. Oh, no answer. Okay. So this one I think you can do on your own first. Try and do yang dia punya calculation for the transformer. What I want to discuss kan yang the essay question. The essay question. Try and see first yang to essay question. I've given you this one. We try and discuss first dia punya jawapan tu, mana tahu keluar nanti dalam exam kan. I don't know. So better we discuss lah kan. We discuss dulu the essay questions that I have given you. Alright. Okay. So referring to this question, diagram 10.1 and diagram 10.2 show two observations in an experiment to study the relationship between current and force that are acting on a conductor. So question A, name the rule used to determine the direction of the force. So what will be the answer for this one? What rule? We will be using what rule? No answer? Dia minta rule kan? So you should write in full dia punya answer di sana tuh. Fleming's left hand rule. Okay. Fleming's left hand rule. So you can write down there Fleming apostrophe S. Fleming's left hand rule. Okay, next one. Question B dia tuh, because this one is 5 marks, so it is very important for you to take out dia punya important points there, because 5 marks kan. So first dia mau, based on diagram 10.1 and diagram 10.2, compare the emitter readings. So we have emitter readings. This one is number 1. Compare the distances of the copper rod motion D. This one is number 2. And then number 3, the magnetic fields of the permanent magnets. This one is number 3. Baru 3 point. We have 5 here. Now the 2 points left is when you state the relationship between magnitude of current with the distance of copper rod motion. This one is number 4. Okay, state the relationship between the magnitude of current with the distance of copper rod motion and the force produced. Okay, so actually ini is the 5th one. Relationship between the magnitude of current and the force produced. So ada 5. So this one you can answer in point forms. Ada 5 lah kan? 1, 2, 3, 4, 5. 5 points for 5 marks. So the first point is comparing this one. Compare the emitter readings. Number 1. Jadi you should start with dia punya aspect. You emitter reading So start with emitter reading. Okay, compare. Try to compare dia punya emitter reading in both diagrams. Kalau comparing, you can use symbol greater than, can use this symbol greater than, less than, ataupun equal. So how is the emitter reading for both diagrams? Which one is less? Which one is more? Emitter reading in diagram 10.1, greater, less than? Diagram 10.2 is more. Yeah, based on this dia punya deflection lah kan. You can see there, the emitter reading in diagram 10.1 is less than in diagram 10.2. Okay, jadi kita tulis sana tu emitter reading in diagram 10.1 is less than in diagram 10.2. Okay. Baru satu markah. Now the second one is to compare the distance of the copper rod motion D. So again, you should start with the distance of the copper rod motion D in diagram 10.1. Greater or less? 10.1 is less. Okay. Yeah, less kan? Guna itu dia punya symbol less than. Because you can see here dia punya distances yang D and this one. Okay, so 10.1 is less. So you should write down there less than diagram 10.2. Okay. Okay, third one, compare the magnetic fields of the permanent magnets. Compare the magnetic fields of the permanent magnets. How is the magnetic field in both diagrams? Okay, cuba tengok. Is there any difference to the magnetic field in both diagrams? No difference, kan? Yes, no difference. Both are using the same size of magnet, so we assume that the strength is the same. So you can write down there for the answer. So again, you start with dia punya aspek di sana tu. The magnetic field in diagram 10.1, because there is no differences, so you can put equal. Okay, diagram 10.2. So sudah habis 3 markah. Now the other 2 remaining marks is by stating the relationship between, okay, yang first one is between magnitude of current with the distance of copper rod motion. So how do we write the relationship between current and the distance of the copper rod? How do we write the relationship? You can use the greater, you can use if then. Okay, when magnitude of current increase, the distance of copper rod motion increase. Okay, correct. Boleh. Can be accepted. Okay, itu yang kamu tulis sana. And then yang number 5, number 5, a relationship between magnitude of current and the force produced. So what is the relationship between the current and the force? Answer? Is it increase or increase decrease? Okay, ngam. Both increase. When magnitude of current increase, the force produced is increase. Okay, ngam. So dapat sudah 5 marks di sana. Okay, ya, ngam. So itu untuk yang 5 marks. Now next part untuk yang C. Okay. Question C. Diagram 10.3 shows a wire is placed between the poles of the magnet. The wire is connected to a sensitive center zero galvanometer. Explain how the galvanometer shows a reading when the wire is moved downwards. Explain how the galvanometer shows a reading when the wire is moved downwards. State the rule used to determine the direction of the deflection of the galvanometer pointer. So actually, from 4 marks, you need to state 3 marks on how to explain how the galvanometer shows a reading when the wire is moved downwards. And then the remaining 1 mark is when you state the rule used to determine the direction. So first mark, apa dia punya first mark? How do we start? Because usually kan most students have problems in answering this question involving explaining semua ni kan. Ini yang part kamu lemah. So again, if 4 marks, then you can use point forms. 1, 2, 3, 4. 1, 2, 3, 4. So we know that yang paling kita tahu sini kan yang number 4 tuh. State the rule. What rule? What rule is that? Fleming's right-hand rule. Because no battery, only motion, then we will use Fleming's right-hand rule. This one we already know for sure lah kan? Fleming's right-hand rule. Okay, dia punya explanation. Number 1. How do we start? When the wire is moved downwards, so you start with that one. When the wire is moved downwards, what will happen? There is a cutting off. Cutting off apa? Magnetic flux. There is a cutting off magnetic flux. Yes, magnetic flux. Itu first point. Okay, second point, what will be produced when there is a cutting of magnetic flux? What will be produced? Induced current. Induced current or induce apa? Induced current, yes. EMF, betul. Induced current or induced EMF is produced. Itu second mark sudah. Now, third mark. Third mark is kejap ah. Induced, we put like this one. Induced EMF is produced. Third one is induced current will flow in the circuit. Will flow in the circuit, making the galvanometer pointer deflected. Deflected. Okay. Simple saja. Okay, make sure you answer in point forms, but your sentences must be full. Okay, so easier for me to mark your answers when you answer in point forms. Direct lah dia punya jawapan. Okay, so this should be the answer lah. Okay, easy to get 4 marks. Okay, alright. Ini last part punya yang I will share you dia punya skema for this essay. After this, okay. Yang ini yang penting sini ni kan, yang the 10 marks. 10 marks punya tu, the diagram shows an alternating current generator. So this is an AC generator because there are the two slip rings, carbon brush. Okay, suggest modification that can be done to increase the output current of the generator. So we want to increase the output current. Increase the output current of the generator. State and explain the modifications based on the strength of the magnet, shape of the magnet, and others. So di sini kan dia sudah bagi 2 aspect. 2 aspect. And the rest you can add. You can add yang the other 3 aspect. Because 10 marks, so there should be 5 suggestions and 5 explanation to get 10 marks. So you have to think lah, what do you need to do with the shape and also the strength. So to answer this one kan, to get 10 marks, usually what I told my students when in KBSM punya kan, yang last year punya form 5 itu, you remember this mnemonic, Uchina. Uchina. Apa itu Uchina? Ini yang kamu ingat to get 10 marks. U is apa? Anyone can guess what is U? So kamu look at this magnet here, the shape of the magnet. What modification should we do to the shape of the magnet? Curve magnet kan? That's why yang dinani U ni means that U-shape magnet. U-shape magnet. Ataupun you can also put the curve shape also can. Curve shape, concave shape pun boleh. Okay? U-shape or curve shape or concave shape. Inilah tuh, this one kan? Kenapa banyak lukisan nih? You can also draw. You can also draw in the suggestion for the shape. If you don't know how to write explain dia punya shape tu kan, you can draw. You can draw the shape. You still can get marks. Okay, and then what is the reason why we use U-shaped magnets atau curve-shaped magnets or concave shape? To produce radial magnetic field. Betul. Atau to produce yalah, ingat itu sajalah. Lebih senang. To produce uniform radial magnetic field. Alright. Nah, okay, yang second one, C. Apa itu C? Can anyone guess? Untuk yang C, use soft iron core. Yes, use soft iron core. And then what is the reason why we use soft iron core? Apa reason dia? Easy to ya, betul Anya. Easy to magnetize and demagnetize. Okay, sudah, itu untuk C. Now we move on to I. Symbol for I stands for I. Symbol for I stands for current. Betul, current. It stands for current. So what should we do to the current? Oh, okay. So because this question dia mau increase the output current, so we cannot use dia punya I lagi lah di sana, but we can use another option, which is, so I cancel this one because dia mau dina kan, so we use B. B lah. B stands for apa? The strength of the magnet kan? Because we are referring to this one, the strength of the magnet. So B, what should we do to the strength of the magnet? Use a stronger magnet. Betul, okay? And then what is the reason for us to use a stronger magnet? To increase apa? To increase the strength of magnetic field. Okay? To increase the strength of magnetic field. So that is the reason. Okay, next one. The fourth one, N. N stands for apa? N. Number of turns of coil. Okay, reason? What is the reason for us to increase the number of turns of coil? So that more current can flow. Okay, and then last one, A. What is A? A is cross-sectional area. So, or you can also put as the diameter. Diameter of wire. What should we do to the diameter of the wire? Increase or decrease? Any answer? What should we do? Increase, yeah. Increase the diameter of the wire. And the reason is because, betul, to reduce resistance. To reduce resistance that causes apa? Heat kan? Ya. Right? Nah, sudah dapat 10 marks sudah. You can get 10 marks by using the acronym di sana tuh. UCINA. But this one, because dia mau minta the output current, so you can ganti yang tuh I tadi tuh with a stronger magnet. Okay? So, itu dia punya jawapan lah. I will share you later dia punya apa tuh answer schemes for this one. Okay, make sure untuk yang 10 marks itu you answer in table form. Or if you don't want to answer in table form, at least you can write one by one lah, not in one paragraph. Don't write your answer in one paragraph. Susah untuk mau cari dia punya jawapan. So it's either you use point forms or you write down your answer in table form like this one. Okay, jangan jawab dalam bentuk satu paragraph itu. Very hard to find your answer. Okay? But any question? Before we end, ngam tidak current loh tempat cikgu. And then my battery also mau mati sudah. Tidak current. No question, ah. So I will post the answer for this one and number 10. Later on, we will try and discuss the answer for mana? Ini, number 11. Number 11. You try and do that one first. Right? Try and do that one. So we will continue our discussion in the next session. Okay? Ataupun tidak payah bincang in number 11. You want us to discuss or no need? Mau discuss juga kan? Mbak? Okay. Right. So next session lah. So we end our session here tonight. Thank you all. Thank you and good night. Okay.